Hello and welcome to my YouTube channel. This is Dramani Online Mathematics. Today we are going to look at non-linear differential equation. We have already looked at the linear differential equation. Then we are going to look at non-linear, okay? But for the non-linear, there's a man who proposed it called Bernoulli. So we named that equation after him, called Bernoulli's equation. Is that okay? So let's look at how it looks like. Now, we said that dy dx plus p of xy equals k of x. If not y to the power n, this one should have been a linear what? Equation. Is that okay? Very good. So we are having some assumptions here that if the n here is not equals to, so if n here equals 1, if that n equals 1, then this one becomes a separable one. So it becomes something that we can easily solve. And when n equals 0, then this one will go, where is it? This n, the whole of this one will go to 1, which will make it linear. So that is the case. So now let's look at how we can solve something like this. When a question like this is given to you, the first thing to do is to make sure that this y to the power n goes to 1. Okay? Meaning that I have to divide through by the y to the power n. So when we do that, here will give us y to the power negative n dy dx. I hope you understand when I divide over. So when it goes to become y to the power negative 1 plus p of x y to the power n minus 1. Hope you understand. Here is power 1. So it becomes like y over y to the power n. So something like this, I can write it as y to the power 1 minus n. Okay. Equals k of x. Is that okay? Because at this point, the whole of this one is gone. So this is what we have. Now the next thing to do is that you let's say z to be equals to y to the power n minus 1. Is that okay? So when you do this, definitely we are going to have dz dx equals n minus 1. So that's when you are differentiating dy dx y to the power n minus what? 2. Because you know that when we differentiate this one, you bring it here, then minus that. When you finish, you try to make dy dx the subject. So let's see. So if I want to make dy dx the subject, what is going to happen here is that I will divide whatever here by itself so that this one and that can stand alone. So it means that I'm going to have dy dx to be equals to 1 over n minus 1 y to the power n minus 2 dz dx. So this is what we are going to have. Is that okay? Now, when I finish with this, I'll come to this place. Here you realize that dy dx, or let me bring it here, dy dx here is here. So I'm just going to replace the whole of dy dx by the whole of this. Have you seen that? Then when I also come to this place, y to the power n minus 1, I'll just replace it by what? Z. Is that okay? So that's how we solve it. So we just look at some examples and try to solve some of them. And a question can be just given to you and they ask you to show whether it's a, or they will ask you to identify, not even to show, identify whether it's a Bernoulli. For you to see that it's a Bernoulli, just like I said, it must be in the form like this. What is here should be the dependent variable, not the independent. So if I have k of x multiplied by x to the power n, it is not nonlinear or Bernoulli. When it's happened like that, it becomes what? A linear one. So we are talking about whatever that here should be what? The dependent variable, not the independent. Okay, so now let's look at this examples. Okay, so Identify which of the following equations are Bernoulli's equation and find the value of n, okay? So we want to find the value of n and you see whether it's a Bernoulli equation or not. So we look at the first one. Remember that this one, I can write this one as t dy dt, okay, plus y squared equals cos t. Even if I divide through by t so that this t comes here, which becomes like dy dt plus y squared over t equals cos t multiplied by t to the power -1. Still not a Bernoulli because this here is what the independent variable. We are saying that whatever that will come here should be the dependent variable. So because it's t, which is the independent, it does not qualify to be what a Bernoulli equation. Does not qualify to be a Bernoulli equation. So that one is off. Now let's look at the second one. So this one is not what? Not Bernoulli. Now let's look at this one. T squared y prime. So we have t squared, so dy dt plus 2ty equals y cube. Okay, so that's what we have here. Now let's look at the y cube is a dependent variable, and anytime that the dependent variable is here and is with the power, then we can say that it is what? A Bernoulli. So here our n is equals to 3 and it is what? Bernoulli. Is that okay? Good. So this one is what? Bernoulli. N is equals to 3. Let's check this one. Theta squared. The r the theta. So since it's the theta, means that the theta is a dependent what? Variable. And the r is the theta is independent, the r is what? The dependent. So if you see the equal sign here, there's r squared here, means that is what? Bernoulli. Because of the dependent variable having a power of 2. So n is 2. Let's check this one. Yes, it's Bernoulli, right? And if you check this, if you divide through, we have y to the power 2. That one too is Bernoulli. So we have power 2 and also power 2. N is also 2. So it's Bernoulli. So the Bernoulli is very simple. The only thing that you have to check is the dependent variable. When you realize that it's having a power that is not 1 or not 0, then you can say that it is what? Bernoulli equation. Good. Now let's take one of them and we solve it. See how we solve Bernoulli equations. Okay, so this is an example, and I hope you can identify that this is Bernoulli. How can you know that this is Bernoulli? Let's write this one. Well, this is t squared dy dt plus 2ty equals y cube. Now you realize that, let's try to write this one in the standard form. See the standard form, there was nothing here. So when you divide through, you're going to have dy dt plus 2y over t. Because one of the t will cancel, equals to y cube over t squared. So these are the standard form. So this one is Bernoulli because of the y cube here. So we say that it's Bernoulli with n equals what? 3. I hope you understand that. Okay. So we said that if you want to solve the Bernoulli, the first thing that you need to do is very simple. You have to divide through by the y cube. So when I do that, I'm going to have y to the power -3 dy dt plus 2y -2 over t equals 1 over t squared. I hope you understand that, because if I divide, this will be okay, and one of the y will cancel the cube, making y squared. But it will be down, so then it will become like this over that. Then we said after getting this, we say that let z to be equals to the one here, not this one, the one here. So that is going to give us only the y, not the whatever that is, only the y. So you differentiate this one, this will give you z dt was negative 2y to the power 3 dy dt. So you divide both sides by the whole of this one, so that I have my dy dt to be equals negative 2 1 over negative 2y cube 1 over negative 2y to the power the dz dt. Okay. So now we move to this place. Dy dt is the whole of this one. Okay, so wherever I see dy dt, I'll put the whole of this one there. Alright, I have y to the power negative 3 there. So I'm going to have y to the power negative 3 divided by negative 2y to the power negative 3 dz dt plus, now y to the power negative 2 is z here. So I'm going to have 2z over t equals 1 over t squared. So this is what I'm going to have. Now, this one will cancel this. So I'm having negative 1 over 2 dz dt plus 2z over t plus 1 over t squared. Okay. So now when you have this, what you are going to do is that let's multiply by the negative 2. So I'm going to have dz dt minus 2, okay, that will give you 4 z over t equals minus 2 over t squared. So now you realize that this one becomes linear. This becomes what? Linear, okay. So now that we have the linear form, now let's use whether the method of coefficient or the integration factor, either the integration factor or the method of coefficients. So now we can use method of coefficient or we can use the integration factor. So I want to use the integration factor. That will be very simple, right? So let's see. Meaning that my p of t will be equals to negative 4 over 2 and then k of t will be equals to negative 2 over t squared. So this is what I'm going to have. So integral of p of t dt p of t is negative 4 over 2 dt. So my u of t equals integral. When I integrate this, I'm going to have negative 4 t ln t and this will give us e ln t exponent negative 4. So this is going to give us, this will cancel this, so that will give us 1 over t power 4. This is what we have. Okay, good. So the formula for this is z of t equals integral of the integration factor times k of t plus c. Okay, this one will be the t plus c, all divided by the integration factor. So z of t equals, the integration factor is 1 over t power 4 multiplied by k of t is negative 2 over t squared then dt plus c, all divided by 1 over t power 4. So this is what you are going to have. So that I have z of t equals, the negative 2 can come out, so that we have 1 over t to the power 6 dt plus c, all divided by 1 over t power 4. Now if you integrate this one, it becomes like t to the power negative, so plus 1 over negative 6 plus 1. So this will give you a t to the power negative 5 over negative 5, like this. So already negative 2, negative 5, that will give us 2 over 5. Okay, that will give us 2 over 5. Then leaving t to the power negative 5 plus c, all divided by t to the power 1 over t to the power 4. So this is what you are going to have. So z of t equals, this one can come to, that becomes 2 over 5 t to the power negative 5 multiplied by t to the power 4 plus c t to the power 4, all divided by, sorry, I've already brought that one top there. So I have z of t to be equals to 2 over 5 t to the power negative 1, okay, plus c of c multiplied by t to the power 4. So that's why we have. So if I'm to write this one, I'm having z of t equals t over 5t plus ct to the power 4. So if I find LCM of this, I'm going to have 2 over 5. I want to find LCM. LCM is 5t, so I'm going to have 2 plus 5 ct power 5, all divided by 5t. But z is equals to y to the power negative 2, means that my y negative 2 equals 2t plus 5ct power 5, all divided by 5t. So this one can be written as y equals 5t, all divided by 2t plus 5ct power 5. So there's a square here, don't forget. Good. Thank you for watching. Try to solve more example. I'll bring more in your way. From here, I'm going to look at the substitution method. And that will be the last topic under this. Then we go to the applications of ODE. Thank you very much for watching.